Chapter 4. ACE the Performance Efficiency Pillar. Introduction. For a busy person who may not have time to go through the hundreds of pages of the well-architected framework, this guide serves as an abstract of the performance efficiency pillar of the well-architected framework. Understanding the performance efficiency pillar will ensure that you are equipped with the knowledge of the best practices in order to make your workload run efficiently in the cloud. The performance efficiency pillar. The performance efficiency pillar includes the ability to use computing resources efficiently to meet system requirements and to maintain that efficiency as demand changes and technologies evolve. The key topics includes focus on selecting the right resource types and workload based on requirements, monitoring performance, and making informed decisions to maintain efficiency as business needs grow. Components. As any of the pillars of the well-architected framework, the performance efficiency pillar also covers the following two broad areas: design principles, definitions. Design principles. Following the various design principles highlighted in this pillar can help you achieve and maintain efficient workloads in the cloud. 1. Democratize advanced technologies. You should make it easier for your teams to adopt and implement new and complex technologies rather than presenting them with a huge learning cliff. This can be done by consuming the complex technologies as a service in the cloud. For example, using Amazon SQS as your message queuing service for your workload may take off the heavy lifting of setting up your own infrastructure for messaging systems, and the team can focus on product development. 2. Go global in minutes. Your architecture should be designed in a way that you can deploy your workload across the multiple AWS regions, which help you reach a wider audience and benefit the end users with lower latency. 3. Use serverless architectures. Instead, if using traditional servers, you can make use of the serverless architectures to run your code. This not only removes the burden of provisioning and maintaining the servers, but also ensures that the managed services scale according to your workload. 4. Experiment more often. With benefits such as infrastructure as a code and on-demand provisioning of your resources, you can test more often to evaluate different types of resources and implement changes to your workload more often than traditional systems. 5. Consider mechanical sympathy. You need to understand how a particular system operates best according to your business goals or workload outcomes. There is no one-size-fits-all option with cloud, and you have the option to select the best resource to select according to your customer access needs. Definitions. AWS outlined 4 focus areas that encompass performance efficiency in the cloud: selection, review, monitoring, trade-offs. Let's go into the details of each of them to understand them better and how we can use them to create an efficient and sustainable workload in the cloud. Selection. It is important to select the right virtual environment for your infrastructure instances, containers, functions, and elasticity. The exercise should start during the design phase itself, as it sets the tone for how your resources are able to sustain production workload requirements. The following set of considerations should be kept in mind. 1. Performance architecture selection. Understand the available services and resources. Rather than just trying to replicate what your resources on-premises workload uses, you should learn and understand about all the available services and resources in the cloud. Define a process for architectural choices. Your architectural decisions should be based on processes which consider the best practices, reference architectures, past lessons learned, and your workload-specific requirements. Factor cost requirements into decisions. You should factor in selecting cost-effective resources when making decisions about your architecture. Options such as AWS Managed Services can help reduce the operational overhead and turn out cost-effective in the longer run. Use guidance from your cloud provider or an appropriate partner. AWS solutions architects and partners have tons of experience from various customers to help you optimize your environment. You can seek their expertise to help you unlock potential for your workloads. Benchmark existing workloads. You can benchmark your existing workload in the on-premises network and use the data collected to drive architectural decisions. Load test your workload. Once you have deployed resources, you should load test the environment to see how the workload performs under stress conditions. By using CloudWatch metrics, you can see the performance of various components and make changes to meet the desired requirements. 2. Compute architecture selection. AWS provides 3 different forms of compute: instances, containers, and functions. Instances. Amazon EC2 instances are virtual servers in the cloud. Depending on the families and sizes, they offer different compute, memory, and storage capabilities. Make decisions driven by data from your workload to select the right instance type. You can further tune the operating system to meet your requirements. Containers. Containers are a form of operating system virtualization which can be used to run microservices or software processes isolated by each other. With AWS, you get an option to select either EC2 or Fargate launch for container clusters. With Amazon EC2 launch type, you control the installation of the EC2 instance by provisioning them your VPC, whereas with Fargate, it takes away the burden of launching and provisioning of compute resources in a serverless fashion. Once the compute resources are decided, you need to choose your orchestration platform. While Amazon ECS can be used to run Docker containers, Amazon EKS is used to consume Kubernetes as a service. Both of them have their own use cases, and it may not just be a binary decision, as both of them can work together seamlessly. You should also consider your application environment and your team experience before choosing the final orchestration tool. Functions. AWS Lambda functions can be used to run your code in an abstracted environment. This is an excellent way to run microservices by uploading your code package and selecting the programming language, memory requirements, and permissions. You can use Lambda with Amazon API Gateway to receive end-user requests by creating REST and HTTP APIs. When you select your compute option, you should also consider the inputs such as GPUs, IOs, memory versus compute intensive, and elasticity. 3. Storage architecture selection. An optimal storage solution selection depends on the following factors: kind of access method, block, file, or object; access pattern, sequential or random; throughput required; frequency of access, online, offline, archival; frequency of update, worm, dynamic; availability, durability. You may also choose more than one storage type depending on your workloads. For example, S3 for the image storage accesses by your users, and Amazon EBS for storing the WordPress files, taking care of your dynamic website. Let's review the 4 storage offerings by AWS. Block storage. Amazon EBS and EC2 instance store volumes can be attached to your EC2 instances. They are accessible from a single EC2 instance and ideal for latency-sensitive applications when the data is mostly accessed from the EC2 instances. File storage. Amazon EFS and FSX offer file storage systems over industry standard as NAS and SMB accessible systems. They can be accessed by multiple EC2 instances at the same time and are suitable when a group of servers such as high-performance compute, HPC, cluster need to access a share file system. Object storage. Amazon S3 provides large-scale object storage option, which the highest level of availability and durability. Being rightly called as the storage of the Internet, it can be used to storage images, documents, and media files for your end users. You can further accelerate delivery of objects stored S3 by using Amazon CloudFront as a content delivery network. Archival. Amazon S3 Infrequent Access and Glacier offer options to store data which, in not frequently accesses, are used for archival purposes. They offer storage at a very low cost, however, come with a high retrieval time. If you need long-term backup solution, then you can consider Glacier as your preferred choice of storage. 4. Database architecture selection. An optimal database solution selection depends on the requirements of availability, consistency, partition tolerance, latency, durability, scalability, and query capability. There is no single database which will meet all the conditions. However, there are databases designed for a specific as well as most common type of use cases. The following database types and services are offered by AWS. Relational. Amazon Aurora, RDS, and Redshift can be used as relational databases if your data has a well-defined structure and there is a relationship identified between them. If your use case includes ACID compliance and strong data consistency, then you should choose relational database for your workload. Key value. Key value databases store data as a single collection without any structure or relationship. Amazon DynamoDB offers you a managed key value database solution, which is typically used for high-traffic web applications, e-commerce sites, and gaming applications. In-memory. For read-intensive applications such as product queries, you can place an in-memory data store such as Elasticache in front of your Amazon RDS database to cache data in memory and deliver microsecond latency. Document. For storing content catalogs and user profile in a JSON-like structure, you can use the DocumentDB, which is a managed document database. Wide column. Amazon Key Spaces for Apache Cassandra is a managed wide column database service, a type of NoSQL database, but the name and format of the columns can vary from row to row in the same table. Typical use cases include high-scale industrial apps for equipment management, fleet management, and route optimization. Graph. If your use case is identifying relationships between highly connected graph datasets at scale, for example, social networking or fraud detection, then you can evaluate Amazon Neptune as a graph database for your workload. Ledger. If you are looking to maintain systems of records, supply chain registrations, or banking transactions, then Amazon Quantum Ledger Database, QLDB, offers transparent, immutable, and cryptographically verifiable transaction logs owned by a central trusted authority. Time series. For IoT, DevOps, and industrial telemetry data which uses time series databases, Amazon TimeStream is a database offering which you should evaluate. It is recommended to use a separate database for different microservices and record real-time database performance metrics to proactively be notified of metrics such as slow queries or system-induced latency. 5. Network architecture selection. There are a few things which you need to keep in mind before selecting an optimal network selection. A. Understand how networking impacts performance. Depending on the workloads and their consumers' factors, such as latency and throughput, can lead to negative or positive impact on performance. For the high-performance compute HPC-related workloads, you need to keep the resources in the cluster as close as possible, and you should place them in a placement group in the VPC while taking advantage of the enhanced networking and elastic network adapters ENA on the EC2 instances. From the user perspective, you should consider using Global Accelerator or CloudFront for minimizing the latency and improving the delivery of the content. B. Extending connectivity to the on-prem network. If your workloads have dependency on the on-premises network, then depending on the latency and throughput requirements, you should either consider a dedicated direct connect connection or site-to-site VPN connectivity. C. Evaluate other networking features. There are cloud-specific networking features which can help you reduce costs as well as improve the overall data transfer performance. By making use of gateway and interfaced VPC endpoints, you can get reliable and private connectivity to public AWS services such as S3. This also reduces your overall NAT gateway data processing costs. For global networks, you can leverage the latency-based routing feature in Route 53 to route requests to the closest endpoint to the user's location based on latency. D. Choose location based on network requirements. There are applications sitting in on-premise network which need to benefit from the cloud offerings but cannot afford the latency or have data residency requirements. Under such conditions, you can evaluate either local zones, wavelength, or outposts, which take the AWS cloud closer to your on-prem workloads and offer a unique hybrid experience. Review. 1. Review your workload. In order to adopt a data-driven approach to architecture, you should implement a performance review process that considers the following. Infrastructure as a code. Define your infrastructure as a code, IaaC, using approaches such as CloudFormation templates or third-party solutions like Terraform. The use of IaaC allows you to uniformly allow best practices for your application code and infrastructure, and also helps you seamlessly innovate at a rapid pace due to ease of deployment. Deployment pipeline. Continuous integration, CI, allows you to continuously integrate code into a single shared and easy-to-access repository. Continuous delivery, CD, allows you to take the code stored in the repository and continuously deliver it to production. Together, the CI/CD pipeline creates a fast and effective process of deploying your infrastructure and releasing your new features. Well-defined metrics. You need to define the key performance indicators, KPIs, of your workload, which can be captured by setting up metrics and monitoring them. The considerations for defining KPIs should include technical aspects, such as time for first byte or latency, and business aspects, such as cost per user transaction or engagement time for an end user. When monitoring them from a performance lens perspective, you should consider trends and business goals to decide if you want to monitor the average or max/min values for the metrics to achieve designed state. Performance tests automatically. Your deployment pipeline should include a test environment which spins up similar infrastructure as the production environment. You should have built-in scripts which generate the load on the test infrastructure to monitor performance and effect of the changes by new builds. Load generation. By making use of canaries or synthetic monitoring, which enables you to consistently see performance of your workload against end-user script. By understanding how your customers experience your application, you can get a more realistic understanding of your workload outcomes. Performance visibility. Various key metrics which define your business outcomes or workload performance should be made visible to your team. They should be able to see the metric changes corresponding to each build to understand positive and negative trends over time. This also enables faster resolution in case of operational events. Visualization. A well-defined visualization dashboard enables you to quickly identify issues as well as gives you an overall picture of your workload performance. CloudWatch dashboards can help you create multiple overall graphs, which enable to see your infrastructure performance along with the workload outputs at the same time. 2. Evolve your workload. AWS continuously innovates to meet customer needs, and you should take advantage of that to evolve your workload. Stay up to date on new resources and services. As new services, features, and design patterns are released, you should identify ways to implement them. Define a process to improve workload performance. You need to have a process to test the performance of the workload against new offerings. This can be using a separate test environment or using synthetic monitoring. Evolve workload performance over time. Based on the data gathered from your workload metrics and testing them against new features and services, you should evaluate the components which would best benefit from evolving with the changes. Monitoring. You must monitor your architecture's performance in order to remediate any issues before they impact your customers. While monitoring consists of the 5 distinct phases of generation, aggregation, real-time processing, and alarming, storage and analytics, all these solutions fall into 2 different categories. Active monitoring. In this type of monitoring, you can simulate the user experience across various components in your workload by running certain scripts. These can be as simple as simulating packet loss in your network by sending ping requests from point A to point B, or creating synthetic HTTP GET/POST requests to add test entries into your databases. Passive monitoring. Usually for web-based workloads, you can use passive monitoring across your users, geographies, browsers, and device types. This can be done by native CloudWatch logs as well as vended CloudWatch logs from your application. Further, you can trigger actions from your logs and metrics to automate actions if the performance is less than a certain baseline. A few things to keep in mind in your monitoring strategy are: 1. Record performance-related metrics. You should identify the metrics that matter for your workload and record them. These can be infrastructure-related and also based on user experience. 2. Analyze metrics when events or incidents occur. If and when an outage occurs, you should review diagnostics logs and metrics to understand their impact on the performance. This provides you with lessons to adopt additional measures to avoid incidents in the future. 3. Establish KPIs to measure workload performance. You need to set up baseline performance and target performance of your workload backed by customer requirements. These help you consistently opt of improvement even if there is no incident or event. 4. Use monitoring to generate alarms-based notifications. Your monitoring system should be integrated with alarms and automated actions to alert your operations team to take corrective actions. 5. Review metrics at regular intervals. Various stakeholders, including but not limited to operations, product, and management teams, should review the metrics at regular intervals. Based on workload changes, you should adopt new metrics to help identify and prevent new issues. Trade-offs. You cannot always get the best of all worlds, and you need to think of trade-offs to ensure an optimal approach. For example, a key-value data store can provide a single millisecond latency for queries, but you will have to design your application to use NoSQL-based queries rather than the traditional SQL-based data access pattern. You can use trade-offs to improve performance by following certain best practices. Understand the areas where performance is most critical. You should identify the areas where the performance of your workload will have better customer experience. For example, a website servicing large numbers of customers spread globally would improve user experience by using CloudFront for content delivery. Learn about design patterns and services. There are many reference architectures which may be different from your current workload environment, but by adopting them you can make them more efficient. The Amazon's Builder library contains various tried and test reference architectures and methods which you can use to innovate your resources with certain trade-offs, but achieve eventual efficiency. Identify how trade-offs impact customers and efficiency. While adopting solutions such as key-value databases may improve transaction times, they also use eventual consistency, which can affect some other workloads. You need to identify what changes you need to make in the efficient use of the trade-offs to make sure their adoption provides customer experience and workload efficiency. Measure the impact of performance improvements. Once you implement changes, you need to measure their impact using metrics to identify if the trade-offs result in any negative impact. If choosing a certain strategy has some unintended side effects, then you can use a combination of performance-related strategies to have a well-architected system. Use various performance-related strategies. By implementing multiple strategies to improve performance of your workload, you can improve the end-user experience. For example, by using caching solutions, you can reduce load on your network and database, and by using read replicas, you can improve the database queries. Review based on performance efficiency optimization pillar. Overall, you should use a data-driven approach to achieve and maintain performance efficiency of your environment. Some of the questions which you will be going through when you review your workload against the performance efficiency pillar of the well-architected framework are: PERF 1. How do you select the best performing architecture? PERF 2. How do you select your compute solution? PERF 3. How do you select your storage solution? PERF 4. How do you select your database solution? PERF 5. How do you configure your networking solution? PERF 6. How do you evolve your workload to take advantage of new releases? PERF 7. How do you monitor your resources to ensure they are performing? PERF 8. How do you use trade-offs to improve performance? The answers to these questions during the review help you identify any gaps in your existing workloads and implement the best practices in your AWS environment.